Hello guys, welcome back to Maths on African Motives. In this platform, we shall be having a continuation on Engineering Science N3, now on friction, which is the question paper which was written November 2022. So we're not going to waste much time. We are going to quickly rush through the questions that we are given. So the first part of the question on 4.1, we are given to state two uses of friction in an engineering workshop. Okay, so we are given an engineering workshop. What are the uses, or what can we have as the uses of friction? And give one example for each answer. So you're supposed to give an example so that you can obtain 4 marks. So is the use, then the example, 2 marks, 2 marks. All right, so we have got some of the reasons that I have here. So I just want you to check 1 or 2 of the reasons. So the first part, it is used to remove material, that is e.g. when drilling, grinding, and cleaning with sandpaper. Also, it is used to transfer power, e.g. You're dealing with belt drives. Then the other part, to prevent slip between two contact surfaces, e.g. when machining tools and the workpiece. So that is the third part that we have. Then the fourth one, to break or stop moving objects, e.g. we are dealing with the clutch of a vehicle. So as we can see here, it's just any tool that you have. So you are giving the use and the example, the use versus the example and so forth. So you just pick any two of your choice from the ones which we have here. So that was a question, the first part of the question 4.1. Let's see the other part, which is 4.2. 4.2 are given to study the diagram. Take note, guys. Study the diagram and calculate the smallest value of x to move the 0.5 ton block up the plane. The coefficient of friction is 0.25. Okay, so this is the diagram that you're given, and it's actually 7 marks to mark everything. So you're given the diagram here. So take note, we need the smallest value of x. This is our x here, x kgs, all right? That is going to move the block of 0.25. This is our 0.25 ton here, where we know mass, remember, 1 ton is equivalent to 1,000 kgs. So if you're given 0.5 ton, you're simply going to multiply by 1,000 kgs. And this is going to give us 500 kgs. So we've got the mass of 500 kgs, which is the mass of the block, 0.5 ton block. Okay, so this is the block that we are referring to. So that's our block here. All right. Then the other part that we are given the coefficient of friction, which is 0.25. All right, so we've got the coefficient of friction here, which is 0.25. All right, so that's what you're given for the meantime. So the question is, what can be the smallest value of x? What is this x representing? Is the mass that is going to put, because remember, this object, which is the block that we have here, is supposed to be moved up of the plane, okay? So this is the direction that you are going to take up of the plane. All right. So what we know is that we have the components that are going to affect this block, okay? In every part of the plane that we have, we've got the components, the parallel component and the perpendicular component. And we know that the total of these can help us to find any of the unknown values that we have. All right, what am I trying to say in this case? Okay, let's start with the block that we have. We are given an angle of 30 degrees in between the block and the plane. So we know that in this case, we shall have parallel to the plane. If we are moving, in this case, this is our plane. So if you are going parallel, so let's just indicate what we can have due to the 30 degrees here. All right, so let's just say we have got something of this nature. So in this case, I'm going to take it, I'm just going to show you the triangle that you're supposed to have at the end. We're supposed to have a triangle like this. So in this case, I'm referring to this 30 degrees, but it's supposed to affect the whole of this part up to the end, okay? But as for me, I'm just going to indicate in this format, all right? But what we have is the whole of this part. So I hope we have the triangle, but it simply means we are representing to the whole of this line down here, and also the whole of this line down here. So we know that due to the angle of 30, this is the opposite, all right? So according to our T, because T is going to affect up to the top here. So this is opposite, and we know that everything opposite carries a sign. So this is going to be T sine of the angle, which is 30 degrees. And here we shall have T cos of 30 degrees. Okay, I explained this in forces, even in that part where I was referring to the right angle triangle. If you are given a right angle triangle, this is your theta, and you are given the hypotenuse here. This side is going to be h, the cos of theta, and this side is going to be h sine of theta. Okay, if you still remember your forces from the forces diagram that I explained, this is exactly the same thing that is happening here. These are trig ratios from your mathematics. I hope we understand this. All right. This is the same thing that is going to affect our theta here. We shall have the resultants as this. Okay, we can just take from our angle. Okay, then affecting the angle theta. All right, let's say this is where we are going to have our angle theta. So what we need is to know the part that is perpendicular and also that is parallel. So according to theta, this is going to be the cos of theta. So it's going to be W cos theta. And we have the resultant part. Okay, not actually the resultant, but we have got our angle theta. Taking at 90 degrees, we are going to have W sine, my diagram. Take note, guys, sorry about my diagram. It's very, very ugly, but I hope we are together on this part. And we have the cos of theta. All right. So what we have here at the end is we have got we have got parallel and we have got the perpendicular, which affects the plane. And of this, we know that there is a normal reaction that we are supposed to have here. We're supposed to have our normal reaction, which is part of the plane, which is our mg. All right. From this information, we have also, all right, let's see, the distance is fine. Then we've got the x here. And all right, I think everything is fine for now. Let's now analyze what we can do from this diagram. Okay, I want you to see something from our diagram here. We have got T, which is affecting the whole of the force that is going to be affected here. And this force that we have is supposed to be equivalent to the force that we shall have due to the gravity. Here, we due to the mass of x kgs and the 5 meters that we have, which is affecting here. But we are not talking about the distance. Remember, due to gravity, which means we are dealing with a g that is 9.8 meters per square second. So what I'm simply saying is that the force that we have, or the tension that we have, which is T, must be equivalent to the force due to gravity that we shall have due to the mass of x kgs and the gravitational acceleration. So this is going to be x multiplied to the gravitational acceleration. All right, so let's just use a proper multiplication here. So this is going to be multiplied to the gravitational acceleration of 9.8. All right. So we do have the value of T. We do not have this value of T so far. All right. Let me indicate we do not have this value of T. Also, we do not have this X. So this is going to limit us again. We only know that our G is 9.8 meters per square second. All right. We do not have P, which is the tension that we have, and also X, which is the mass that we are supposed to calculate. All right. Due to the plane itself, we can formulate equations here from the plane, which can help us to calculate the value of T and the value of, if we can have the value of T, therefore we can have the value of X. All right, because these are the two missing values. If we can have one T, then we can have our X. All right, so let's take to the parallel part of the plane. Okay, let's just write something aside here. We need components parallel to the plane, okay? Component parallel to the plane. Parallel to the plane. All right. So according to our plane in this case, we need, or we know that if we are dealing with parallel, guys, if we are saying this is parallel, we have got our plane like this. So being parallel, we are referring to something of this nature, that is being parallel to the plane. All right. So what do we have in this case? We need to combine all the ones that are parallel. So what we need to know is that the ones that are going to the left must be equal to the ones which are going to the right, if we are dealing with a parallel. All right. So which are the ones which are going or which are referred to the left? So to the left, if we are to check, guys, being parallel to the plane and going to the left, we are referring to this t cos 30 because it's like this here. It's supposed to be going this direction. All right. So we've got t cos of 30 going to the left. All right. That is the only part for now that we can talk about, because the sign, okay, what is the direction here? The sign, the W sign is supposed to have our direction in this manner. That is our W sign going to the right. All right. Then when there is a tension T here, which is going to give us T cos 30, it's going to be opposed in the other direction. And we know, guys, everything which opposes the movement is the friction. So here we shall have our friction force, which is now going to the right. So to the right, we have got the frictional force going to the right. We also have the W sine theta, which is also going to the right. But to the left, we have got T cos 30. So the one which is to the left must be equal to the sum of those which are moving to the right. So we said we've got T cos of 30 to the left. So this is what we are going to have. So we've got T cos of 30 degrees, which is moving to the left, is equal to the ones which are moving to the right. And to the right, we said we've got the frictional force and the W sine theta. So we've got the frictional force, all right, and plus the W sine of theta. Okay, let's see, guys, if you are going to win. Remember that W is equivalent to mg. So this is mg, all right? So that means we can substitute something there from our W. All right, let's see if we can have our W, because this is mg. All right, do we have the mass of the block? Yes, the mass of the block is given. If we are to check here, we said the mass of the block is 500. That is our block here, and the mass of the block is 500. So it's going to be 500 times 9,8, which is the gravitational acceleration. All right, so we've got, all right, let's substitute, guys. This question was very, very tricky. So we said we've got the mass of 500 times the 9,8. All right, so if you multiply properly, you must obtain 4,900 newtons. All right, that is, you can substitute here, and also you can even simplify cos of 30 if you want, but we can just leave it like that. T cos of 30 degrees is equal to the frictional force plus the W, which is 4,900 Newton sine of theta. Okay, so where can we have the frictional force in this case? All right. So guys, we are still trying to figure out what can we do in this case. How can we work out, or how can we simplify further? All right. For the meantime, I want to leave these two at this stage here. I want to leave this at this stage. It's gonna be an interesting question, the way it looks here. All right, but let's leave it like that. Let's go to the perpendicular. All right, let's move on to the perpendicular. So these are the components, sorry. So we now move components perpendicular to the plane. All right. So perpendicular to the plane, it means this is our plane, so it's going to be like this. It must meet the plane at 90 degrees. So which means we are referring to all the ones, all the forces which are going up and all the forces which are going down. So in this case, what I'm simply trying to say is that the forces which are going up should be equal to the forces which are going down. All right, is it clear, guys, or not? Okay, let's see. What is going up? What is going down? Okay, so we are going to refer here. All right, we are going to refer back. Let's refer back here to our diagram. Let's refer back to our diagram here. All right, so this is our diagram, guys. If we are to check the ones that are going down here, let's have our diagram like this. We are going to see that the only part that is going up here is our N. Okay, this N is going up, which is the normal reaction. And here we shall have this part. All right, so let's just say these two will be opposing each other. Okay, the N and the W, they are opposing each other. Okay, because they are on the same block. So N is going up, W cos theta is going down. So this is going to be equivalent to the T sine of what? Of 30 degrees. So you're going to take this one upwards. Okay, so you're going to take this one up. All right. So this is going to be the resultant that we are going to have. This must go up. Remember, guys, we must have a diagram like this. This going this direction, this going up, and this will be the resultant. Okay, so I'm simply saying the resultant that we shall have for T sine of 30 is supposed to be the difference between these two, because W cos 30 is going down. Okay, so I was supposed to actually write my W cos 30 on this part. Okay, I think we are together there. All right, so we are going to have this here. Let's take our force. So I said the one going up, the T sine of 30 degrees, all right, that's sine of 30 degrees must be equal to the difference between N and the one that is going down. So it's going to be N minus W cos of what? Cos of theta. Here we've got W cos of theta going down. So you're going to subtract W cos of theta. So if we subtract W cos theta, that means we have got an equation that we have formulated. Yes, we have got an equation that we can work from, or that we can use to simplify or to find the value of T if possible. Yeah, we can, because remember, guys, what we said here, we can find T, okay? If we can find T, that means we can find the value of X. So whatever that we have for now, it consists of T. So let's try by all means to calculate T from these values that we have. So how can we calculate T? All right, let's check. Let's substitute here on this one, just like the previous one. It's going to be T sine of 30 degrees is equal to N minus W cos theta, of which our W in this case is 4,900. So it's 4,900, the cos of theta. All right. Then the question is, if we are to check now, we have got two equations, guys, that we have. Okay, let me indicate the first equation here, the second equation here. We are saying if we can calculate T, it is going to be easier. We have got T here, we have got T here. All right, but if we are to check on this equation, we have got the frictional component here, which is the frictional force without T. All right. Also, we have got N here without T. So that means, guys, this is going to be very, very difficult. And also, we do not have theta. We do not have theta. We do not have theta. So we must write these values, N and the frictional force, in terms of T. So write the frictional force and the normal reaction in terms of T. All right, in terms of T. That can help us now, because remember, guys, this is mathematics. In your mathematics, you know that we can't solve this, like we have got 3 unknown values. It's impossible unless if it was 2 unknown values. But if we can write in terms of T, that means we are left with 1 unknown value, and we can solve those equations that we have. All right. So theta, where can we have our theta from? All right, let's get back to the diagram. We can calculate theta here, because if we are to check according to the diagram, we are given this, according to theta, we have got the opposite side, which is 5 meters, and we've got the adjacent side, which is 25 meters. And we know that this is going to be from tan, which gives us opposite and adjacent. So remember that tan theta is equivalent to opposite over adjacent. So we can calculate theta. So let's just use this space aside here. So let's calculate theta. So the tan of theta is equivalent to the opposite over the adjacent. So to find theta, theta is going to be arctan, the opposite over the adjacent. All right, that's the adjacent here. So theta is going to be arctan, the opposite. All right, that is our opposite is 5 and adjacent is 25. So that's 5 over 25. All right, 5 over 25. So this is going to be 5 over 25. Then our theta is going to be something like 11, okay, let me just show you the screen so that we can even use, okay, I'm already showing the whole of the screen. I forgot to put back. Okay, anyways, let's see what we can have here. We are referring to arctan. So this is shift tan, 5 over 25, like this, 5 over 25. All right, that's 25, which is going to give us 11,399, which is 11,31. Okay, so that's 11,31 degrees. All right, so we have the value of theta in this case, which is 11,31. So which means we can even substitute here our theta. All right, we can substitute our theta. But we still have unknown values, which is here we are left with any, and we are left with the frictional force. Okay, before we are given that the coefficient of friction is 0.25. All right, so let's work with the coefficient of friction. We know that from the coefficient of friction, this is what we have. All right, let me write it down here. The coefficient of friction is supposed to be the resultant of the frictional force over the normal reaction. So that means we can play around these two. All right, our frictional, the coefficient of friction is 0.25. Okay, so this is 0.25. So that means we shall have 0.25 equated to this. 0.25 is equal to the frictional force over the normal reaction. So we can play around these values to either make any the subject in terms of the frictional force, or to make the frictional force in terms of what? In terms of N. So you choose which one is best for you. Okay. Let's say I want to make any to be the subject here. What am I going to do? I can cross multiply, because already, why am I trying to make N, guys? This is simple. Here we have got the frictional force, okay? So if we can change our N to be written in terms of the frictional force, that means we simply have to just subtract the equations, or we can play around simultaneous equations, guys. Okay, I'm going to show you later on. Let's see what we're going to have first. Okay, we are here. So we said, let's make N the subject. So you're going to cross multiply. That is going to be 0.25. That's 0.25 N is equal to, this is 7 over 1. So we've got the frictional force here, divide by 0.25, divide by 0.25. So that means N is equal to, so here it's 1 divided by 0.25, which gives you a 4. So that's 4 times the frictional force. All right. So this can be represented in place of N, or you can write in terms of the frictional force, because we can see if we are to write it in terms of the frictional force here, it means the frictional force is equivalent to N over 4. If you wanted to write frictional force in terms of N, you could have written it like that. Okay, so now let's get back to our equations, guys. From those equations that we had, we are going to substitute these values that we obtained. That is our theta and all these values. Okay, so let's start with equation 1. All right, from equation 1, we have got t cos 30, all right? So we can simplify this t cos of 30, all right? We can simplify this cos t cos of 30, all right? That means we are going to have, let's check. Okay, let me just write it as a fraction, guys. This thing of simplifying for me, it gives me a lot of value. So I'm just going to leave it like that, which is equal to the frictional force plus 4900 sine of theta. So this is sine theta. Remember our theta, we calculated theta here is 11,31. Okay, so you're gonna substitute now 11,31 degrees. Okay. All right, then we can simplify. If you want, you can combine these, but for meantime, let's leave it like that. Okay, let's just leave it like that. Then, okay, this was equation 1. From equation 2, we are going to do the same, all right? From equation 2, this is what we have. This was our equation 2 here. We have got t sine of 30 degrees, which is equal to n. N is 4 times the frictional force, okay? That is our n. We have substituted n minus 4,900 cos of theta, and our theta is 11,31 degrees. Okay, so we have two equations here. All right. From these two equations that we have got two options that we can do to solve for t. Remember, you want to solve for t. Okay, I think I indicated this before. All right, I indicated where. Okay, let's check here. I think, yeah, here I indicated that we are supposed to calculate the value of t. If we can have the value of t, then we can have the value of x. All right. So for you now to solve for t from these equations, what can you do, guys? This is now you and from your mathematical skills, guys. All right. It's either we can make from equation 1, we can transpose and make the frictional force the subject of the formula from our equation 1, because we want to calculate t. So you can make the frictional force the subject. We also make the frictional force the subject, so that these two will be equal in values. All right. So that means from equation 1, we are still on equation 1. Make the frictional force the subject. Okay, that's the subject of what? Of the formula. So which means the frictional force is going to be equivalent to, I just have to transpose this to the left-hand side. So you're going to have 2t cos of 30 degrees minus 4,900 sine 11,31 degrees. Okay, we do the same thing on equation 2. We make this the subject. So if we transpose this, it is going to add. Then you divide by 4. Remember, there's a 4. So which means your frictional force is going to be equivalent to the t sine of 30 degrees plus 4,900. So that's 4,900 cos 11,31 degrees. Okay, so everything you divide by 4, because it was going to be 4 times the frictional force. So here you are going to divide by 4. Here you divide by 4. Okay, so we have made the frictional force to be the subject from the two equations. All right, so this is what is going to happen, guys. If these two values are equal, there is no way. It means if these two values are equal, what you're going to do is to simply equate, because we've got the frictional force and the frictional force from equation 1 and from equation 2, and these two, they are equal. If these two are equal, therefore it means also these two are equal. So you can equate these two equations. So what am I trying to say? We can have our equation now as t cos of 30 degrees minus 4,900 sine of 11,31 degrees is equal to the whole of this part, which is t sine of 30 degrees, everything over 4, plus 4,900 cos. Okay, so this is now cos 11,31 degrees. All right, everything over 4. So that's what you're going to have at the end. So these are two equations that you're supposed to solve. Okay, so these two are equal. So you can solve for t. By collecting like terms, we can solve for t. That means we can simplify this to the other side of the equation. Is going to subtract. So we are going to have t cos of 30 degrees minus t sine of 30 degrees over 4, which is equal to, if you transpose the minus 4,500 sine to that side, is going to add. So it's going to be 4,900 cos 11,31 degrees over 4 plus 4,900 sine 11,31 degrees. Okay, so this is what you're going to do, guys. We need to add this part with sine. So you just have to add here. What are you adding? Because this is t and this is t. So you simply add cos 30 minus sine. So it's a minus. So it's minus sine 30 over 4. So this is what you're going to do. Let me indicate this so that we can see our calculator. So we are going to have this on our calculator. Let's see. This is going to be cos 30. So we've got cos of 30 degrees like this minus sine 30 over 4. So it's going to be sine of 30 degrees, everything over 4. All right. This is going to be 0.7. Okay, that's 0.741. Okay, so we've got 0.741. So we've got 0.741 t, which is equal to, you simplify on the right-hand side, everything on the right-hand side. So this is what you're going to have, a fraction here, 4,900 cos 11,31 degrees, everything over 4. Okay, subtract. Okay, it's a plus, so it's plus 4,900. Okay, that's 4,900 sine 11.31 like this. All right, so that's it. We have got 1,86 if you round off properly. So that's 2,162.186. So divide by 0.741, divide by 0.741, both sides, this can cancel. We have got the value of t. All right, so that was it, guys. So t is equivalent to, if you divide properly, you're going to obtain something like 2917,93 Newton. Okay, take note, guys, what was the purpose of calculating this value of t? So that we can have our x. All right, so taking this value of t, we are now referring back to that equation that I showed you before. All right, so let's get back to this equation. Remember, I showed you here that here, this was the equation. X multiplied by g should give us t, or t is equivalent to x times g. So that means we can substitute all this here to calculate now the value of what? Of x, because t is equivalent to x times g, and we calculated our t, we obtained t. So if to calculate x, just divide by g. So that means x is equivalent to t over g, which is our t, which is our tension. We got 2,917,93 Newton over g, our gravitational acceleration of 9,8. All right, so if you divide properly, guys, you're gonna have your x, which is 297,748, and this is mass measured in kgs, x kgs. All right, so that was the whole procedure, guys, the diagram and so forth. So I just hope we understood, and it's very, very important that we must have a question like this, another question like this. You actually understand everything, what I'm trying to say, and also just to have a normal understanding of the diagram. Okay, if you are given a new diagram in exam, analyze from what you have done before. You know about perpendicular components to the plane, parallel to the plane. We use that information. It's a certain type of question that you have seen in exam. But can you use the given information that you have done before to calculate whatever that you are given in exam? Because exam is not about what you have done before, but you use that information to answer the new question that you might face in exam, because most of us, we left this question in exam because we're saying we never had a revision like this. Yes, it's true, but we were supposed to apply that basic information about what we have done before. That was going to help us. But anyways, we shall try by all means to work with such type of questions in future case so that we prepare ourselves enough for the exam. So that's what we had, guys, from Maison African Motives, still on engineering science N3 till we meet again.